Good morning, everyone. My name is Steven. Wait, why am I doing an intro? Okay, you guys know who I am. I am today doing... Oh, first of all, yes, I was at the airport last time I streamed. And yeah, I was moving yesterday. I was not able to stream. So today we are moved in, sort of. So I have a lot of stuff, and I don't have my monitor set up. So again, I'm going to be recording on my MacBook. And yeah, I'm starting my last year of school, and for undergrad at least. And today my goal is, so I stumbled upon this guy, Zi Wu, who works on video generative models. And I think it's important to sort of understand, sort of like what's happening in this field. Because particularly I'm interested in understanding like if these models can actually understand physics, right? Because like at the end of the day, he's just trained on like large scale video data, right? And somehow by training on this large scale video data, the model has to learn like how the physics actually works in order to generate reliable video models. So it's sort of like the physics is not a direct objective, but because it is forced to generate like realistic images and it gets punished for that, the model is sort of forced to learn the actual physics of how things move, right? Similar to how like language, we never taught like these LLMs what correct grammar is, right? But it's been forced to learn that because of the like it has to learn this underlying structure. Like it can't overfit to a particular data set because we gave it like such a wide like data set. So first of all, I don't fully understand how these video generative models work, and I suppose this is like, how do you fine tune the fusion models for your own preference? My mental model of like how these VLMs work is is it a VLM or is it like in robotics where you have a VLM and then it's a diffusion head at the end? How does that exactly work? Also, there's one more thing, I guess. Also I should not use my personal account. Let me close this. Oh, that's my GPU. Let me close these stuff and switch to my streaming account. Okay. And Ziwu. And we do want Grok. And allow okay. There's like different personalities for Grok, right?
Yeah, there's a few versions of me out there. Each one's got its own vibe, but we're all here to help with answers that cut through the noise. I'm Ara, the one with the upbeat, friendly tone, ready to dive into whatever you're curious about. Want to explore something specific?
Yes. Yes. Is this too loud? Hi. Yes. No, I think this is fine, right? Yes. Also, is the...
So, is there something specific you were wondering about? Just let me know how I can help.
Yeah, I want to understand basically how these video models are. Are they basically VLMs? Because like in robotics, you have VLAs. And with VLAs, you sort of have like this VLM head, and then you slap an action head, which is like you generate actions to like some diffusion process or flow matching. And I wonder for like these video generative models, how does this actually work? Is this also like some sort of VLM? By VLM, I mean it's gonna have like a text tokenizer and some sort of image token. In this case, there's no input image. The input image is raw like noise, right? So it's not quite your sense of VLM, right? It's because these are generative models, whereas the robotics VLMs that we use is like as input, it has both the original image and the actual text, and then they share some sort of embedding. Like it goes to like the encoder, the transformer encoder, encodes both the image and text into some different tokens, or like and it tokenizes it, and then there's some embedding, and then you can use that embedding which is like some latent representation of like what the actual image means, image and text means, and you use that to train. But for video generative models, you don't have like, your goal is to generate an image, right? I guess you have in painting, but you sort of like, well, do you even take anything? Like, I guess you take your text prompt. So take a text prompt and then like a Gaussian noise, and then it generates the image via diffusion, right? Is there like an LLM in this whole equation? Like, how does this look like?
Wow, you're really diving deep into this. Video generation models aren't exactly VLMs in the same way robotics uses them, but there's some overlap. Let me break it down quick and clear. Video generation models, like OpenAI's Sora or others, are primarily generative models, often built on diffusion processes. They start with a text prompt, which gets tokenized and encoded into a text embedding, usually by something like a clip text encoder. This captures the meaning of your prompt, like a cat surfing on a rainbow. Then, instead of taking an input image, like a VLM in robotics, they begin with random Gaussian noise in a latent space. This noise is gradually refined through a diffusion process. Think of it as iteratively sculpting that noise into a coherent video, frame by frame, guided by the text embedding. The core architecture often involves a transformer, like a diffusion transformer, DE, which handles both the text conditioning and the noise to video generation. Unlike VLMs in robotics, which combine image and text inputs to produce actions or descriptions, these models don't need an input image or video. They generate everything from scratch. The transformer processes space-time patches of latent video representations, blending spatial and temporal data to make the output smooth and realistic. Now, about LLMs. Some video models do integrate large language models to enhance text understanding or smooth out generation, like aligning visual tokens with LLM processes for better coherence. But the heavy lifting is done by the diffusion model, not a traditional LLM. The latent representation is key. It's like,
can you just stop talking?
Got it.
Where's the text that you just said? Like, what the
Oh, I don't have a visible text output. I'm just speaking right now. If you want, I can summarize what I just said about video generation models. They use a text prompt, tokenize into embeddings, start with Gaussian noise, and use a diffusion process with transformers to create videos from scratch.
Are they still called VLMs?
No, video generation models aren't typically called VLMs. That term usually refers to vision language models, which handle both images and text together, like in robotics for processing input images and text to produce actions or descriptions. Video generation models, like Sora or Runway's Gen 2, are more often just called generative video models or diffusion-based video models, since they focus on creating videos from text prompts and noise via diffusion, not analyzing input visuals. They do use text embeddings, but the process is distinct from the VLM setup in robotics. Want me to clarify anything else?
Yeah, so Grok's a bit glitchy. Okay, let's read through, some of this work. Right, so there was a paper I read like a few months ago. Physical principles. I think it was this one. The answer is no.
Welcome back. Now, again, we think a lot about architectures. That's one of the kind of exciting things that gets people, a lot of people get excited by all of the cool architectures you can try on a new machine learning task, especially in physics-informed machine learning. And there is a zoo of possible architectures just for neural networks. And I want to make an important point. Not all machine learning is just neural networks. There's a lot of other architectures that are not neural networks that we can use to learn models from data. But even within the realm of just looking at neural networks, there is.
I think it was Costas. That I saw it from. Costa. Search. Hmm. Yeah, probably not Costa. Hmm. Hmm. Why is the Wi-Fi so slow, boys? Lol. Sora is actually the best. Wait, oh, Sora is the worst? Lol. Lol. This is funny. Pico just doesn't move.
Welcome back, everybody, to another
changing color in midair or something.
Well, this is... Yeah. Alright, let's skim through the paper again because I don't think I really read it. And how they actually benchmark this physics understanding, right? Like, I think that's an important detail. Also, guys, I'm really, really hungry. I ran this morning. I ate one meal yesterday, but you know, over the freaking break, I got really fat because I got my wisdom teeth removed and I could not run. So now I need to suffer to make up for it, and it's really hard. I'm like hungry, really, really hungry, and yeah, I don't know what to do because I'm so hungry. So this is what I just said, right? Proponents are like, because of the way they're trained, predicting how videos continue, you're forced to sort of like understand physical principles. Now, interesting. They're saying they cannot distinguish correlation from causation. Like, embodied AI is actually how you can get these world models to understand physics. Right, that makes sense. Solid mechanics. I'm so hungry. Don't think about being hungry. Think about the paper. Alright, so the videos are 8 seconds? Like there's some like distance. No, there's a glitch and everything. Metrics.
is strong generalist because the simple integration of
some scenarios need the
So the first method to mitigate hallucination is called introduce negative data. So this idea is from paper LRE instruction. So this paper is designed to introduce both the positive and negative instructions for more robust instruction tuning. So you can say just like the example in the last slide. The first 6 examples for positive example, positive instruction may have about maybe the object detection task, maybe like OCR task. And in the for example in model, you can say it has like different manipulation strategy, to
Dude, it's all Chinese guys, bro. Like, what the hell's going on?
and
Introducing chat. Reasoning. Dude, this is like... Huh. Okay, like, can we just like... Data-driven robotics. Like... Oh yeah, this is core. Like, do you have I guess they're like only tutorials. Like, is this like specific to CV? All you need about self-driving. Oh my god, bro, just like... Okay. Oh. Mm. I see, so this is rare, where they... Like, this is, you know, a compiled, like, reading list is like... People should do this more. Who's Lucy she?
Hi, Riva. Can I have a sandwich with roast?
So they're doing hierarchical. Oh, I did not read this. Holy shit. Oh, Lucy's the main author. Damn. It's cracked.
bus embodiment. I think we
for the tasks that Polyformant could not get off the ground. So it
Very interesting. Coral 2024. Sorry guys, I'm getting a bit distracted, but the fact that we have I like this MLM tutorial has like so many great papers you can just go through, right? Like this is really good. I wish people did that more, for people like me who's a noob and like doesn't know like what papers to read. Of course, like this is like quite noisy, right? Like I think like robot. Okay, but today we're just gonna do world models, or sorry, generative diffusion models. What is this though? There's like so many tutorials. Holy shit. Towards building AGI. Wow. Dude, this is insane. Yeah, I'm good on AV. So they don't, because based on measuring these, there's also like 29.5%, whereas you should get 100%. And they measure it based on these four metrics. You know, like IOU, like different IOU, like is it paying attention to the right object, and do video. When, and where, how much weighted spatial, and how does the action happen, so that you get the same color, etc. Right? Okay. How are the masks generated? That's a good question. And instead of reading, try again. Okay. Alright. But yeah, they don't have physics understanding. It goes through some algorithm. We don't need to understand too much more in detail. What we want to look at is these work on slot former and slop diffusion. So slot former was the first piece. Like object-centric models. Can you help me understand object-centric models in the context of video models?
Sure. Object-centric models in video focus on identifying and tracking individual objects across frames. They break down scenes into separate entities, like people or cars, and analyze their appearance, motion, or interactions over time. Unlike traditional video models that treat frames as a whole, these zoom in on objects, making them great for tasks like action recognition or scene understanding. Think of it as giving each object its own spotlight in the video narrative. Want a deeper dive into how they're built or used?
Yeah, what's the history of object-centric models?
Object-centric models trace back to early computer vision efforts in the 2000s, when researchers started tackling object recognition in static images. Around 2010, advances like deep learning and convolutional neural networks, CNNs, pushed things forward, letting models pick out objects with better accuracy. By the mid-2010s, people began applying these ideas to videos, combining spatial data from CNNs with temporal tracking, often using recurrent neural networks or optical flow. A big leap came with models like Mask-RCNN in 2017, which segmented objects in images and inspired video extensions. Around the same time, researchers developed object-centric video models like video object segmentation.
Okay, shut the fuck. No, you need to do it in latencies. Or is this just like answering what's in the image? Oh my god. Oh, Ocelor is in Brazil. I have them? I'll have gym. Okay. Yeah. Yeah, focus is really hard when you're hungry, huh? So there's slot form and then slot diffusion. Wait, so I was reading slot diffusion. Oh, it's a very OG paper. Like these, how do these three just like? Where is Ian Goodfellow right now?
Was tested on millions of scenarios. Corners. This is a long time ago. Sorry guys, I can't focus. What does this paper do?
combining both. Okay. The Vigilante is not as good. Elegant and effective. It's like the attention, like what object are you paying attention to? Okay, I can continue reading this tomorrow. Alright, I'll see you guys. I'll cut it short. I'm gonna get to work. I'm gonna eat some food. And then actually do some schoolwork and then work on research. But yeah, reading this will be a hobby thing that I'll continue to